today we're going to be talking about the atom. Have you ever wondered why the electrons go around a nucleus like this? Let's think. If the electron is orbiting around the nucleus, that means that it is accelerating since it's constantly changing direction. Since it is accelerating and the electrons are electrically charged, that means that the electron would be giving up energy in the form of light. If so, that means that the electron is losing energy and eventually it'll fall into the nucleus, which will be the end of our existence. So clearly the electron does not orbit the nucleus in this way. Then how does it really circle the nucleus? So let's go back in time. So you know how Newton shined sunlight onto the prism and the prism separated the colors to create a spectrum like this? In the 1900s, scientists did the same thing with hydrogen and got this spectrum. How do hydrogen atoms emit light? If you run an electric charge through hydrogen atoms, the electron will absorb the energy and get excited and moves to a higher energy level. When it falls back down, it releases energy in the form of light. In the hydrogen emission spectrum, there's only 4 colors, meaning that the electron can only absorb 4 colors. Thus, there are only 4 energy levels an electron can jump to. If the electron absorbs a red light, it will jump from here to here and emits a red light, and so on and so forth. Furthermore, when the electron moves up to a certain energy level, it cannot pass through any other level. The electron had to disappear, then reappear into that energy level. It's like if you're on a ladder with the rungs of energy levels. To go up, you cannot go in between rungs, otherwise you fall off. You must directly go to the next rung. Okay, so electrons have energy levels, but it's still orbiting around the nucleus, meaning that if accelerating, it will collapse. Perhaps electrons are not only particles, but also waves like light. What if there were waves where each electron node a higher energy level? This would explain why electrons can only have certain energy levels, and you can't have partial wavelength, only whole wavelength. Now, our atom looks like this. But this still doesn't solve the issue we had before. Waves are still accelerated motion, meaning that the electron will still be accelerating and collapse. In 1926, Schrödinger uses complex math to create the wave function, turning the Bohr model into a 3D wave, with the shape of the atom changing depending on the electron's energy level. But the electron's location doesn't just depend on energy level, but 3 other numbers, making the shape of the hydrogen look like this. Furthermore, the electrons are a wave themselves, but rather waves of probability. It's not that the electron stretches into the form of a wave. It's just that the location of the electron is unknown, and the probability of where the electron might be is in the form of a wave. What if we try to find out exactly where the electron is? Whenever we do, the electron stops acting as a wave and collapses into a particle. It's like this box with the ping pong ball as the electron. When we don't measure where the electron is, it takes the shape of the box. But the moment we open the box to see where the electron is, it collapses into a particle. What does this mean? Well, we don't really know, and that has led to many different interpretations, such as the ensemble, Copenhagen, and many world interpretation. But let's stick to the facts for now.